Good morning, everyone. I am Narmatha, working in Dr. S.N.S. Rajlakshmi College of Arts and Science in the Department of Cybersecurity. In today's lecture, we are going to discuss about block cipher and Feistel cipher. So first, we'll see about modern block ciphers. So if we look into modern block cipher means here we are splitting a plain text into different blocks. That block will be encrypted and it produces the ciphertext. Here we are using different algorithms, cryptographic algorithms. So by using that algorithms, will convert our plain text into ciphertext. So here we are using so many design principles to perform all these operations in block cipher. Block cipher versus stream cipher. So here block cipher is fully about we are splitting a plain text into blocks, and in stream cipher we are splitting that into bit by bit. So here how we are taking a characters means we are taking 64-bit characters in block cipher, but in stream cipher we are taking single bytes for the conversion uh, for encryption and decryption. So many current ciphers are block ciphers because we didn't use stream ciphers now. Uh, Here it performs bit by bit. So so many people are not using this stream ciphers. So the pictorial representation of stream cipher and block cipher is given here. So first one is stream cipher using algorithmic bit stream generator, and the second picture it shows a block cipher. So in the first picture, we are sending a key and that will be sent through bit stream generator algorithm. So after combining key and bit stream generator algorithm, cryptographic bit stream is generated. After that, that stream is combined with plain text to produce the ciphertext. So the opposite of this is performed for decryption. In a block cipher, what we are doing means the key is uh, along with plain text, we are sending a key to the encryption algorithm. Here we are using different encryption algorithms. So by combining all these things, it produces a ciphertext. So simple operation we are performing in block cipher. So here we have some principles for block cipher. So it is like a symmetric block algorithm. It uses the structure of Feistel cipher. So if we are performing a decryption operation means we need to recover message efficiently. Mainly we are using this block ciphers for extremely large substitutions. For example, 2 power 64 entries. If we are having 64-bit block means it has 2 power 64 entries. So instead of creating a smaller building blocks based on the size, we can split up different blocks. So this is the pictorial representation of ideal block cipher. So here we have 4-bit input that will be sent to decoder. That decoder sends that information to perform the permutation. That means it interchanges the values what we have given. So after that, that interchanged permuted values will be sent to encoder. At last, we'll get the ciphertext. So in this form, we are performing it. Here we are concentrating on two things: substitution and permutation. So substitution and permutation is a very basic primitive to perform block cipher. Here Along with that substitution and permutation, we have two things, confusion and diffusion. So diffusion means it is a statistical structure of a plain text over bulk of ciphertext. So confusion means it makes relationship between the ciphertext and key as complex as possible. Feistel Cipher structure. So it is based on the concept of invertible product cipher. So it has partitions input block into two halves, processed through multiple rounds, performs a substitution on left data half based on round function of right half and subkeys. Then we are performing a permutation swapping for another of. So it implements the substitution and permutation for that two halves. Here the pictorial representation of Feistel cipher is given. So we are splitting whole block into two different blocks. So left hand side, right hand side. For both the sides, we are performing substitution and permutation. So at last, we are performing a swapping to swap the values what we have given in that. So this is also the different rounds what we are performing in Feistel cipher. So what are all the elements that we have in Feistel cipher means block size, key size, number of rounds, subkeys, generation, round function, fast software encryption and decryption, and ease of analysis. Thank you. So from this video lecture, you'll understand about so what is a block cipher, and in block cipher, what kind of structure we are using. So here we are used Feistel cipher structure to perform the operations of substitution and permutation.